All right, so the first unit is actually about angle measurements. And we're going to see that there are two types of ways of measuring angles. One is the degrees, which is most common. So we kind of have an idea what that is. We use this in real life. But this is not the only way of measuring angles. There is also called the radian measure, which is more scientific or technical, if you wish. Very useful in math, engineering, and other type of STEM, fields. We're going to cover both. So obviously, the main goal of this unit is these two measures, the degrees and radians, and how to convert between them. Related to the angle measurement, also we're going to see that we have what's called cardinal angle, different kind of angle, and we're going to see all those definitions as well. All right, so unit 1, let's start with the definition, what is an angle? So since we're going to be talking about angle measurements, we need to start with an angle. So an angle is basically just two rays that intercept on a common point, which we call the vertex, okay? If you have a point where the two rays intercept, so let's say this is my first ray, this is my second ray, the amount of space between them, let's say if I rotate from this side, which I call initial side, the one that I start with, and then from there I rotate to form the position of the second ray. The measurement in between is actually our angle. And that measurement, as I mentioned, we see that we can describe this in two different ways, which is degrees and radians. But the initial side, you rotate the other ray up to a certain position. When you stop in that particular position, that's called the terminal side. So the other ray is the terminal side. Now, you see here that the textbook shows you a very nice picture in a different orientation. Notice that the initial side is sitting like on a tabletop, right? It's horizontal. And I didn't do mine horizontal, meaning it's up to the person to draw that angle in any position the person wants. But that's not very ideal, because if we are discussing angle measurements, we need to have a certain standard. So what we're going to get through is that what's called the standard position for angles. So meaning, if we're talking about the standard position, we all agree on what that look like, what's the position of the initial side, where the vertex will be, and then basically the rotation to the terminal side, which is the amount of angle, will be the measurement we're concerned. So basically everything else is going to be the same. It's just the position of the terminal side and how much of that angle will really matter in order to describe the angle. Okay, so measurements and degrees, most commonly done. Okay, so that's next. So for degrees, we actually use the symbol, the little O that goes horizontal. So if I'm talking about 30 degrees, there's the little O that goes into that. It's like the same for temperature, right? So degrees has a way of expressing. When we move on to radians, though, there is no need for expressing. So if you don't see anything being mentioned, and we're talking about angle, that becomes automatically radians. So we're going to get to that. All the examples you see there in terms of angle, they are all what we call standard position. And again, I'll get to that standard position in a minute, but notice that the initial side sits horizontally, right? And then the terminal side rotates to the left counterclockwise, meaning the opposite direction that the hands of a clock would run. And that's considered the positive direction of rotation for angles. So if you are with a certain angle, and you always start from the horizontal position, right? So this is my initial side. Now, of course, this is my vertex. And then I'm going to rotate a certain amount in degrees, basically to my left, rotating to the left against the clock hands. So meaning this direction. So that's the positive direction. Now, if the terminal side somehow is between 0 and 90 degrees. So 90 degrees for us, we know that is the right angle, 90 degrees. So if it's something between 0 and less than 90, so meaning somewhere around in the middle here, you're gonna have what's called an acute angle. So this is all the angles that are between 0 and 90 degrees. Of course, the angle equals 90 degrees exactly, which corresponds to a quarter rotation, right? Because a rotation, if you go from the beginning, from the initial side and rotate all the way and come back to the same position, you have a full circle, a full rotation. And that full rotation corresponds to 360 degrees. Okay, but not all angles go a full rotation. And here we have the example where we have the right angle that I mentioned before, which corresponds to 90 degrees, that has a specific name, the right angle, and that corresponds to 1/4 rotation of the full rotation, right? So we're talking about just a quarter of the full rotation. If the angle is greater than 90 degrees, but less than 180, okay, and 180 means that basically have the initial side and terminal side like flat, so that is the straight angle, and that is exactly a half of the full rotation I have. So this is a half of the full rotation I have. So that's the right angle. But if the angle rotates somewhere up to between 90 degrees and 180, somewhere right here, that is called an obtuse angle. Okay, so those are just terminology for a specific type of angles. Probably gonna mention later, and just be aware that that's what they mean.